Hello, good day, everyone, from wherever you are joining us across the world. Welcome to day two of Data Science Nigeria AI Everyday Virtual Bootcamp. We know every one of us want to sustain our learning during this lockdown, and that is why we at Data Science Nigeria, have created this platform to engage our community, both in the industry and on campuses, to ensure that everyone is up to date and at the cutting edge of knowledge. Just to talk about ourselves again, Data Science Nigeria is a non-profit organization with a vision to raise 1 million AI talent in 10 years. And of course, you can be part of this vision as we focus on delivering high impact and transformation research, business use case application, AI first startup, employability, and social good use cases. Part of what we do at Data Science Nigeria is that we offer bespoke training programs aimed at scaling up professionals. These are some of the companies that we have trained. We offer bespoke training programs that are customized to an industry to meet the training need of an organization or to accelerate the analytic skills of an individual. We do a lot of data and analytics training for professionals where we bring industry experts to facilitate hands-on and project-based sessions. In addition, we deliver hands-on and practical training sessions in areas such as robotic process automation, data engineering, game theory and mechanism design, data science for marketing, data science for HR and people analytics, data science for banking, for fintech, and for insurance, and many more. Please visit www.datasciencenigeria.org/trainings to discover more. And the way it works is that our paid training and consulting services help us to fund our free training programs. We are on board to run the biggest AI learning program in Africa with 29 unique platforms that are face to face, online, offline, and hands on training that has impacted hundreds of thousands across the continent. Some of our training programs include AI Everywhere, which is a 6 weeks program in many cities. At the last edition, we trained over 1,000 students across 17 cities. Now, to sustain the amazing impact that I've made via the course training, we have what we call the AI Plus Club on campuses and cities. We also have Artificial Intelligence Bootcamp, which is the biggest and most competitive inter-campus learning platform in Nigeria. Now, at the last AI Bootcamp, which was just last year, we had 30, over 30 international and local experts who facilitated the sessions at the bootcamp. Please feel free to download our annual report via this link. Now, today, we are excited to have Dr. Kingsley Okoye. Dr. Kingsley is a data architect based in Mexico. He will be leading the session on putting data science in action through process mining, a way of problem solving for business leaders, students, and researchers. Dr. Kingsley is passionate about giving back to the community. He is a mentor at Data Science Nigeria. He has his bachelor degree at the prestigious Nnamdi Azikiwe University here in Nigeria, and thereafter he completed his master's and PhD program at the prestigious University of East London. Ladies and gentlemen, please make welcome Dr. Kingsley Okoye. Thank you very much.
Hi everyone, welcome to the day two of the Data Science AI Bootcamp. My name is Kingsley Okoye. I have a PhD in software engineering and a data architect by profession. Today I will be sharing with you a topic called putting data science in action through process mining. Today, as we all know, data science is a profession of the future. It is an interdisciplinary field that aims to turn data into real value. Organizations are collecting data at an unprecedented rate, and there is now more than ever increasing need for experts who are capable of extracting useful information from the said big data sets in question. So today I'll be looking at the concept called process mining, and how we can use this technique called process mining to put data science in action. And then we'll look at some of these techniques by describing the event logs, typical characteristics of an event log, and what constitutes the minimum requirement for any process mining analysis. And then we will look at some examples of the process mining tools and different types of process models that exist currently in the literature. And then I will be showing you some practical case study implementation and demonstration of this process mining technique. And then finally, we will make some conclusions and look at some questions and answers that you guys will have for me. So let's dive into it. Process mining. Indeed, not only are the different organizations that fail to leverage the big data in a smart way not survive or meet up with the rapidly changing today's competitive business environment, but also there is more than ever increasing the need for the business process owners or analysts to make use of insights drawn from these existing data sets to support the business operations, and also to help in the decision-making processes in the diaspora. According to Van der Aalst, one of the best-known BPM researcher and the forefather of process mining, he says that it's not enough to focus only on data storage and data analysis. And as a consequence, the data scientists need to relate data to process-related analysis. What does it mean? This means that most of the existing data analysis methods focus only on data and the information that are derived from analyzing the data sets, without throwing emphasis on how those information or data can be used to understand the different organizational processes in real time or real world settings. So therefore, process mining is one of the existing techniques that aims to bridge the gap between the traditional model-based process analysis and data-centric analysis techniques, such as machine learning or yet even the data mining techniques. In essence, process mining seeks to resolve the gap between the big data sets that are stored in the different organizations' information system and the business models in reality. In other words, the process mining techniques makes use of the data mining and process modeling techniques to find out patterns from event logs without prior information on how those activities have been performed within the execution environment, and then allows for further analysis of the discovered models. Even though the process mining is a new field that has existed for just over 2 decades now, the resulting methods and algorithms can be applied to any type of business or operational process, provided the event logs contains the minimum requirement required to perform the process mining task. In fact, or in short definition, all of such tools and methods which are used to support the process mining tools have one thing in common, which is that the observed behaviors or discovered patterns, which are normally extracted from the existing data sets, need to be related to the process models in reality. Thus, we refer to the process mining as data science in action. So what does it mean here? We mean that process mining starts at the bridge between the event logs and the business process model. So businesses or organizations can actually leverage the process mining through the use of data sets to keep going and to keep the operational processes strong and up and running. So next, what we'll be looking at here is the event logs for process mining. Process mining algorithms use event logs to learn and reason about the processes by coupling in a technical manner the event history data and the process models. So any data science technique or process mining technique, we all know starts from data. The main aim here is we're trying to focus on how can we extract useful information from this data? How can we use these data sets to make informed decisions about the processes from which the data sets are being extracted from? So today I will be specifically talking you guys through on the typical data sets that are required to perform a process mining task, and then we can again dive in to go ahead and see how we can use these data sets to extract useful information that can be used to maybe foster organizational decision-making process. So first, event data can come from a wide variety of data sources and formats. For instance, database systems, we know different information systems that store data in different formats. For instance, we know the common file format, just Excel spreadsheet or the CSV files. And then also there is this extensible event stream, which is the standard format that is currently being accepted in the literature. I think it's been formalized by the IEEE Task Force on Process Mining, which is the standard format that is expected that any process mining tool that is being developed by the software developers or vendors should ensure that the software is supporting these extensible event stream format. And this file format is not about a typical XML file, like we all know. And then there is the the previous one, the mining extensible markup language, which is being supported by the early process mining tools, which was now reformed or being, any process mining tool can actually still use the XML file as well, but these are mostly supported by the older versions of the process mining tools. But recent process mining tools are expected to support the extensible event stream format. And also there is the extensible event stream extension as well, which tends to add more of a description to the data sets as well to help the analysis get more easier. And then we know that these data sets can come from any transaction log, like for instance, a trading company or a business transaction system, for instance, a banking system. And also, we know that data can come from a business suite or enterprise resource systems, so like SAP, Oracle, etc. And also a message log like the IBM middleware, and any open API providing data from websites or social media or etc. And says, data can be collected about anything at any time, at any place. So, and then the most important thing, which is the essence of the data science today, or the AI tools that are being implemented today, is to take this data and provide methods or techniques on how we can extract useful information from these data sets has been stored in different formats. So continuing on the development for process mining, the typical requirement for any process mining analysis is that the data will have what we call a case ID and also activity labels or attributes, which represents the bare minimum to perform the process mining task. Additionally, there are other information that may be required for ample implementation of the process mining techniques. For instance, the dataset might need an event ID for ordering of information in order to discover casual dependencies in the process model. Also, some datasets can have timestamp, resources name, maybe persons that perform the tasks and so on. Why we go down or why we do the practical implementation, I will go ahead to show everyone these attributes that is being represented in the data set. For instance, if we look here, this is a typical Zex file that the process mining tool uses. For instance, you can see that we have the activity names here, the resources, and then we'll have the timestamp, right? And then also, I think we can still find the roles, which are the resources, the performer, and so on. So this is a typical file that can be supported by the process mining tool. But nevertheless, there are other simple file formats that every process might need to accept, like the simple Excel spreadsheets where you have the colors representing the attributes and so on. So, as we go on, I will explain these things in detail, especially when we go into the practical bits of today's section. So, what are the steps to performing process mining? The first step to performing process mining is the availability of event logs. Event logs can be collected about the different activities that underlie any organizational process. If we take, for instance, a purchasing company or a supply company, they always have what we call different steps or activities that underlies this organizational process. For instance, they will have like people requesting for an order, the order is being processed, the order is being shipped, the order is being delivered. So these are the different steps that are being recorded in any organizational information system. So what process mining does is to take these recordings or these activities that are being captured, right, in order to understand how the actual process is being performed, and in order to discover, for instance, bottlenecks, and then go ahead and maybe make a kind of recommendations on how the process can be improved. So the first step is to have this data recorded in any format as we've described before. And then the next step is to take this data and apply what we call the process mining algorithms, which we will still look at in the next few slides. So the process mining algorithms, there is a lot of process mining algorithms right now, and the case scenarios depend on what the user is proficient with, or what the user wants to use, or the case analysis, or the settings, or the type of data that is available. So there are a lot of process mining algorithms, but the main aim is to apply these algorithms in order to discover what we call the process maps of visualization, the process models, which gives us a typical illustration of how these processes have been performed. And for instance, if you look here, we could see this is one of the process mining tools which I will be explaining or be using today to do the practical implementation. So, and then this, what we call, every process miner will have what we call the case ID. In this case, I call it the label process ID. And then we'll have the activity name, which also is being assigned an activity, and then the timestamp, end time, event type, who performed the activity, role, so on and so forth. So this is what we call like a typical example of data that you can find in a spreadsheet. And then this is what we call the process mapping, which the process mining go ahead to reconstruct this data set to provide what we call the process map. And then the process map is what the process analyst will use in order to interpret this data, draw insights, and explain these data sets. And then also, now, I've already talked about this, which is now the results of applying the process mining algorithm on the data sets, which will now provide what we call the process models, which are used to automate or visualize how the different activities are being performed within the process execution environment. And then finally, we have what we call the business intelligence, whereby the process analysts, data analysts, business owners are able to draw insights, are able to come to some kind of conclusions or consequence of some underlying processes that is being done, activities that is being performed in order to support the business process decision. So there should be a kind of, after processing the process mind, there could become kind of informed information that is being derived by performing the process mining. So these are the simple steps to perform a process mining. And then also we have an example of the most common process maps that is being discovered, right, as a result of the process mining. For instance, we have the fuzzy model, which is this kind of a fuzzy model, which is as a result of applying the fuzzy miner. And then we'll have the Petri nets, and we'll have some process mining algorithms like the alpha algorithm, inductive miner that are able to produce what we call the Petri nets, right? And then we have the process trees as well, which is a typical example of a process model that you can discover by using the inductive visual miner. And this is like an example of process tree. And they will have the business process, the business process modeling notation, right? Which the ones that use the event logs like or gate, no gate, in order to explain the activities and the sequence of activities or how they are being performed. And this is an example of a BPMN model. And then we'll have, a lot of the genetic model, genetic process mining models, and then we'll have the like or the heuristic nets, and then so on. So I think today I will be explaining and talking you guys through about the process discovery tools which can be used to discover process models. I think here we have the process mining tools and software providers. I mean, there are lots of process mining tools out there that you can use to perform your process mining. And then also there are, different kind of software providers. Most of them offer open source, which you can use freely to perform your process mining. Also, some of them offer like paid subscriptions with some giving you like academic initiatives as well. Like I know Flozy, they do offer what we call the academic initiative, whereby a lot of institutions subscribe to them and they are able to give the researchers probably they give you a kind of a limit, some limited access to the software, which you can use for research purposes. And also have the process mining workbench, which is the mostly used process mining to today in the literature, right? And so these are, some of the like MyNeat, MyVenue, Promo. We have the Signal View as well, which offers a academic initiative as well, whereby you can, if you're a member of any institution, you should be able to subscribe to these platforms using your institutional addresses or institutional access. So from here, so what we'll be doing today will be to show you, you guys, how you can go about maybe downloading these softwares, installing them, and how you can import data into these process mining platforms, and also how you can go about analyzing these data sets, and then we use some of the examples of the data that exist there in order to do these analysis. So first, what I would do would be to show you how to do what we call the process discovery, like I explained before. How do we take these data sets and then discover models that can give us information that we can actually interpret to understand how this process is being done. So what we'll do will be to show you guys about one of these software providers that's called Flozicom. So Flozicom is a very useful tool to discover your processes, right? And when you go to flozicom.com, all you just need to do is to click on the products. So when you go to flozicom.com, it brings you to the home, into the home environment where you can read a lot of information. For instance, I mentioned to you about the academic initiative, right? So the support process mining research and education as well. So if you go to the academic initiative, there is a lot of institutions that have subscribed to these platforms, right? These institutions, what they do is to enable their students. All you just need to do is use your student account to supply to these platforms. This could they offer the demonstration. Just like a free trial, the demo version of these softwares, which will allow you to import maybe a limited number of data sets. But when we're talking about big data here, they do offer what we call the paid subscriptions or academic initiatives. So there is a lot of institutions, you see, that have actually subscribed to this tool. So if you are one of these institutions, you should be able to have access to this software, to do your analysis. So now that we're already here, so what we'll do will be to, again, go back again, and then you see how we can look at the products. And then when you click on the products, it takes you to where you can actually download the software, right? If you're using a Windows, I'm using Mac, It's showing me that I can download for Mac. If you're using a Windows, it will give you a link whereby you can download the software for your Windows. So all you just need to do is to go ahead and click on the download button, and this code will be downloaded, right? So once you download it, you just need to install it. It will ask you, I mean, this is the demo version. If you have your academic license, I mean, they will send you a code, to access this thing, give you a license code to access the academic licenses, which also enables you to, import a larger amount of data. And then there is that one of every software provider provides what we call the preview version, whereby you can use it to process, any amount of data that you want to. So this is a Disco. So once it's downloaded, all you just need to do is go ahead and install it, right? And I'm going to cancel this because I've already installed this on my computer. So once you install Disco, you just need to go ahead and open this software. So for instance, if I want to install this, I will just have to drag this to the applications. And also a very good thing about this software is it gives you what we call an example data set as well, like you can use to test out this data. There is lots of example data sets out there. We'll be choosing one today to illustrate how Disco can be used to perform process mining tasks. So what we'll do will be all you just need to do is follow the instruction, install it, and then open Disco up. So here I've already opened the Disco, and here what we'll do will be to now show you a typical example of how to do a process mining analysis. So I have here. So I have here some example data sets which I've already downloaded from some of these websites, right? So what I'll be doing is to pick one of them, like you see, like you can pick these example data sets. This is an example data set that I've actually downloaded from the processmining.org website. These data sets is about like a typical process for a company that does what we call repair of electronics. So we'll be looking at the different steps that this company takes in order to take an electronic or gadget that is not working from the users or the client, and then go ahead, fix it, and then communicate back to the clients. So this will be the example data sets that I'll be using to illustrate the data analysis today. So here we are already in Disco, right? So all you just need to do is to go ahead and import your data sets. So what we'll do will be to minimize this so that we can actually view the screen a little bit more. So for you to import data sets into Disco, all you just need to do is to go to the import tool and then click on open file. And then I have my data sets here. So I'll be choosing these data sets for this analysis, okay? So what I've done will be to open it up. And now this is a typical example of the data set for process mining analysis that I've mentioned before earlier on to you guys. So in these data sets, we have what we call the case ID and the activity ID. So which means that these data sets meet the minimum requirement that we need to perform any process mining. So now what you need to do will be to go ahead a little bit. Sometimes the process mining tool will do that automatically for you. But for the case ID, you need to ensure that you assign it as the case ID. And also have the activities that have been performed, like register, analyze defect, test, inform user, repair complex. These are the different activities that makes up the organizational process, right? So what we've done here will be to assign this as the activity name, and then we'll have what we call the resources, like who at some point is doing any of these activities, like the system registration is being done by the system, and then we'll have like analyze defect, have what we call the tester one, who are the resources, right? People that work in the company and all that. And then we'll have the timestamp as well. Sorry. So we have the timestamp, which is already assigned here. as the timestamp again, and then you have like a start time for each of these activities. So these activities have been performed and then completed at this time as well, right? And then we have other useful information like the variant index. I mean, these informations as well might be useful while we're doing our analysis. But the most important thing to focus on is that you've already assigned like the case ID to the case ID, then the activity to the activity, and then timestamp will also be assigned to the timestamp. And that's it, you're done. So all you just need to do is to go ahead and import these data sets. So boom, I mean, the process might need to automatically construct these data sets to give us a typical view or flow of how this organizational process looks like. So here in these process models that are being discovered, first we'll start by showing you guys the threshold. Good thing about Disco is that it has what we call the threshold, right? It gives you, that opportunity to, set how you want to view these processes, right? To see if you want to focus on the activities, you can set accordingly on how you are able to view the process normally or good for your analysis. So this is the first thing that we've done here. Then the second thing is to actually look at the discovered model here. So in this model, we'll find out that, for instance, we have what we called this is the number of cases that is being handled in this organizational process, right? So we have about 1,104 cases or clients or users that have been registered on the system, right? And then the system goes ahead, or the organization go ahead to analyze these gadgets or these devices that is being brought to be fixed, and then they go ahead and analyze the effect. So once they finish analyzing the effect, you see that they send this for repair sample, or they send it to the repair complex, and then at the same time also they have to inform the user. Probably maybe when the gadget is fixed, or then they will inform the user. And then there is another one like whichever way or regardless of which type of repair is being done. For instance, if the repair sample still goes to the test repair, then if it's the repair complaint, it still goes to test repair as well. And then there is an interesting activity here that is going on here, which is the restart repair, right? It's a kind of a rework. Probably maybe they try to fix it, it meets the user requirement, or the system didn't work, or maybe they tried this repair simple, it didn't work, and then they have to restart by sending it to whatever happens there, but maybe we can find out that in this process there is a rework being going on, and sometimes most of this rework sometimes can cause what we call bottlenecks, or problems or delays within this process. And then in any case, again, once the test is completed, they always send it to a card, for instance, maybe documentation, or that the document is being completed. The gadgets have been completed, and probably the gadgets ends here. So now there are a lot of things we can do with this process model in order to understand what's going on here. For instance, again, we can see that there are some activities as well that, for instance, that are still pending, that are not yet completed, right? So, and are still expected or anticipated that they will be completed at some point in time. So the first thing that we can do with this data will be to go ahead and do what we call inspection, right? So we look at the cases, right? So there is a lot of variance going on here, and the highest valued variance, the one that is about 22.92% of the data set. We have the different cases or events going on here, and these are the variants, right? So typical, most of the variations that is going on in this data are the activities that goes through, like a register, analyze the effect, and then repair complex, inform user, test, repair, and then archive, right? So this is like a typical process that goes on here. There are other variants as well that is going on here. So once you click on, for instance, each of the variants, you can still go ahead and inspect each of the case. But one thing that this code does that is very interesting or very useful here is, I mean, we can't actually go ahead and be inspecting all these variation. I mean, this will take a lot of time to do. So there is a simple way in order to understand what's going on here. So in that case, all we need to do is to go to the statistic tab. So here in the statistic, there is a lot of options or lots of information that we can gather from here. So first thing that will refer you will be to we can check what we call the mean case scenario, right? This is the average time it takes for one single case to be completed, which is about like 1 hour 6 minutes or something for a single case to be completed. But first, we need to just go to the case scenario. First, we will look at the data that is a little, I mean, the data, I could say, looks like it's normally distributed. And you can find out that the most cases, which is about 75 cases, takes about 55 minutes, like 1 hour to be completed. So, I mean, this can give you, I mean, a quick view of what's going on in the data set, right? You could look at number of cases, like you can say like 54 cases we completed within the 52 minutes and stuff. So, but then, what can we actually deduct or do with what's going on here? We have some interesting little bits of cases that are here. For instance, that takes even up to like 2 hours 40 minutes, and some takes about 2 hours to be completed. So this is what we call like the kind of constraint, right? Because usually we have the main case scenario, which I mean, averagely is expected. He said that it's expected that a case should be completed like within 1 hour 6 minutes. Right? Let me say 1 hour 10 minutes, basically on average. So we can do what we call a bottleneck analysis to find out why these cases maybe is taking long, and probably try to find out what could be the problem here. So this is the first analysis that we can do using Discord. So for we to do that, what we need to do is to go back to the process map and then filter, right? So here we're trying to add a filter and we're trying to see the performance view, right? This performance view will give us this uh, again information, and then we can now narrow down to these cases. For instance, we can say let's look at the cases that takes more than 1 hour 10 minutes, right? Okay, let me leave it here like 1 hour 12 minutes, right? So we find out that about 32% of our reference data contains, I mean, have been completed over 1 hour 12 minutes. So we're trying to dig to find out some useful information that will tell us what is happening or what might be causing these constraints, right? So what we need to do is now to go ahead and copy this filter. And then why I'm copying it is so that we can keep the original data that we have in case we need to do other further types of analysis, which we will still do today as well. So what we'll do will be to label this filter, like I will say, check for problems, right? Check problems, data. And now we can apply this filter permanently and then create it. So the disk now gives me a different type, again, of model representing that percentage of data that we have. Like here, we can see that we have the original data sets, which is here, and which is still keeping its original format that we can filter as well. But now we have what we call the reference data sets, which are also created here. So the reference data sets now is giving me 351 cases which have been completed above 1 hour 10 minutes, right? So here we can have a quick view. Can we look at, for instance, we can look at the frequency part to see the most frequently taken parts. For here, we can see that the repair simple, between the repair simple task and test repair, there are a lot of cases going on. These are like frequently performed activities. Again, from testing to archiving as well, we can see there is a lot of frequently visited activities here. So this is like giving us a general overview of what's going on in the data. But again, for we to do bottleneck analysis, first we'll say we need to change over to the performance view, right? And we can start with the mean duration. So here we can see that we have another information here that will be useful for us. Okay, here we find out that there is some interesting parts that is being events happening here. For here, we have we can see like it takes an average of 16 minutes for the organization to analyze the device that is being sent for repair and sending it to for a comprehensive repair for those which are recommended for complex repair. An interesting thing is that even the compressed repair as well takes a bit of time. Like it takes about 33 minutes to an average to fix or to handle any events that come here. Again, there is an interesting thing that is going on here. Even though we find out, for instance, we go to the frequency uh, tab, we could find out that even though there are lots of events that is being done here, a lot of activity going here, if we go to the performance, we find out that these events are actually being done instantly. So, I mean, a process analyst or me, I wouldn't be concerned about, if there is a bottleneck here. So, what we actually will be concerned with would be to try to see why these bottlenecks or these reworks has been done here and trying to find out maybe, this is where the process analyst starts making their recommendation, starts drawing their report to present to the people that have asked for the process analysis to say, the data is showing us that, there could be the kind of delay, from the time the device has been analyzed, that there is always a bit of delay before it's being sent for repair. Even while it's sent for repair complex, takes a bit of time in order to complete the repair complex before sending it to the test. So this is the first type of analysis that we could do. Another type of analysis again that we can do here will be to look at the total duration, which again sometimes is very handy in reconfirming the information that we have. What the total duration does is to put both the frequency in the loop as well. It puts both the frequency and performance into loop by checking out, averagely or in total, what these processes or what are the consequences or the delay time or the bottlenecks are for this company. So for this company, again, we find out that now again, most of the delays is being done. For instance, it takes an average of 3 to 6 days to do the compressed repair, which takes again a total of about 40 hours to send a device from the analyzed defect to the repair complex. So I think, again, what we could do again would be to leave this total duration and then add another secondary metric, like just for we to see further information, we can add the median information, or like I've explained before, we could put the mean. So what this does is to give us, again, for instance, it gives us that it takes a total of about 42 hours, and these are the mini average that it takes to complete this process. So, this is one of the types of bottleneck analysis that we could do. And another thing, again, we could do would be to do the animation. So animation will always give us like how the typical process flows, right? So for instance, the person to register and analyze the Fed, now this case is being sent, this is like a single case, or the yellow dot is for a single case. The case is sent for simple repair, and then the user is informed, and then the testing is being done. Again, there was a kind of a restart repair, which goes to the complex repair that takes a bit of time to process before going back to test repair and then archiving. So this is the kind of typical case that happens within the process, and you can actually identify the reworks, and also the animation gives you the threshold where you can actually set maybe to see the activities coming in. on the fast rate, okay? So we can actually spend time to view what's going on in this model, right? We have about 4 cases now being analyzed. So you find out that what interesting thing is find out that once an activity goes to repair complex, take a bit of time for it to be processed, and any activities that goes to repair simple, I think instantly move. It's being processed and instantly move to the test repair, just like the information that we found out before. So animation is very quite handy because it gives you, it could be handy when you're presenting the data to your clients, trying to explain where the bottlenecks like or what's going on in the data sets. And uh, generally to have a general overview of how these data sets are being performed or what the constraints of the bottlenecks could be. So this is the first thing that we can do with process mining, which helps us to understand these data sets and everything. So another thing again that I will show us today again is there are another. This is the first thing. There are two other things, or a number of things that we could do with data sets. For example, we can decide to find out what's the typical process. The typical. First time get it right? Like, without any real work, what does a typical process for this organization? What does it look like? Or what will be the typical process that will save number of time, that will not cause delays, that will save the company such delays that we have here, like the bottlenecks and the rework. So for we to do this type of analysis again, what we could do again would be to go back to the first data set, the reference data set, right? And then to explain what I'm trying to say here will be to first we'll look at, because we understand in this data there are some incomplete data sets, right? So that's another thing that we can actually focus on. How do we remove or exclude these incomplete data sets, because it does not actually give us information about what this typical process, or what, for instance, a process that is being complete without any rework or bottlenecks, what does it look like? So a process that is still waiting, I think there is every tendency that these repair complex can will not go straight on to end. For instance, it might go through the restart, reworks, and stuff. So first, we can now go ahead, right, and filter out these data sets. I will filter out these reworks or these incomplete data sets cases that is being that is existing within the model. So for we to do that, first what we need to do is to click on that link, and then we follow this. So now what we're actually trying to do is to exclude that from the data. So we just need to do like the invert selection. So which excludes this now from the model, and then we'll apply the filter. So automatically we find out that that incomplete data sets are gone. So again, we can just go ahead. This is what we call like model cleaning or data cleaning. We can go ahead and clean out these little bits, and then again we'll do the invert, apply that, and then again we'll remove this incomplete process here. So just about it then. And then again, that's the first thing that we could do. And then again, to clean up this data again, in order to find out what the typical process for this organization will be to look at the restart or reworks, right? So for instance, these restart repair, we find out that the rate of processes that goes, for instance, this is the complete process, right? So, sorry, the repair complaints. So the repair complaints is meant to go for test repair, but we'll find out that there is some that actually still goes to restart, for instance, right? Or before probably maybe going back again for simple simple test. So this is what we call like a loop. There is a kind of a reworks going on here. You inform the user, again, it goes back to restart. So we find out that this is not like a kind of a typical what's expected in this organization. So what we could do would be to go ahead again and remove all these reworks that is going back rather than back and forth. Again, you can go ahead and filter that out by following the same process. Again, these are the process. Again, it's interesting here because I wanted to let me show you. So now we find out that this process is right, goes back to the repair complex, this particular part goes back to the repair complex part. So we want to exclude this particular this part. So what we need to do is, because this one now goes to the restart repair, and that's the repair complex that it goes back to. So we mean that this directly follows this, right? So what we could do would be to go and set it as never directly followed. So if you apply this filter, so automatically the repair complaints now or the restart is there, and the process has been the part has been excluded from this process model. Again, same procedure, we can go ahead and remove this again, which goes back directly to the restart repair, or exclude that. So same procedure, never directly followed, apply. And then again, this goes back. So see, so we can remove all the reworks that is actually going back and forth. So this is the repair simple and test. So which is like a typical, this is like a typical process, right? So this one, we can go ahead. And then these ones as well that goes from analyze effect directly to so here we can see that now we have what we call a little bit presentation of what a typical complaint for this organization will be, which is first we'll have about 735 cases, and then we'll have 735 cases that is being completed, right, or is being archived. And now again, if we add up, so the typical normal scenario for this company will be when a user registers the device that is faulty, then the system will analyze, the tester will analyze to see where the defect is. And based on the findings here, we'll either send this for a repair complex or for a repair simple. And find out to add up these cases that have gone for the repair complaints, like 524 plus 211. Find out that these two cases actually adds up to 375 cases, right? And again, the user is being informed, which are the number of 735 users that have registered. They are being informed, about the repair, if it's done or not. I mean, anything that goes on within this process. And then we have 735 repairs and archive. So this is what we call like a kind of a first time get it right without any restart, repair, or reworks going on. So this is like a typical process. I mean, that the organizations go through. So another interesting thing would be actually to again look at the cases again. I mean the statistics again. Takes about 60 minutes, 1 hour on average to complete this data. We can actually again go ahead and which is we have about, this is now about 66% cases of our reference data sets that have actually gone through the normal process, or without any reworks or, or any loops. So again, we can actually again go ahead and look at this. Maybe to confirm the information that we have right now to see again why some of these cases. So let's look at the statistics again. So we'll find out that actually this is like a typical, it takes about 1 hour to complete a task, and then we'll find out that some actually still take up to 1 hour, even though they've gone through the normal company procedures. There's still some that takes even up to 2 hours to complete. So what we could do again would be to do the same analysis that I've told you the last time, by going back to the process map, trying to filter that out, add a filter, performance filter, and then we can again go back to since we are looking at 1 hour here, so we can choose the data sets that are completed maybe for between, yeah, that will be fine, like 48%, right? So finally, 48% of our new sets of data again, I mean, have what we call bottlenecks that we could look at again. I mean, it's quite interesting because this will actually, again, give us information to confirm the information we have before that. Is it actually the problems that we find out before? Does it still apply, even though these processes are they followed the first time get it right? Maybe some of these delays that is going on, can we actually know maybe why they have a bit of delays and how can we go ahead and resolve it? So this is the one good thing that process mining gives to you. So we can copy again this new data sets and save it, or probably we could save it as a new bottleneck analysis, right? And then apply this filter, and then we create that. So we can find again, looking at this process model, we find out again that we have the register. I mean, there is a interesting frequently passed that is going on here between analyze defect and informing the user, and then between analyze defect and the repair complex again, test repair complex. We have a kind of quite outstanding processes. I mean, parts that is being performed in this process, but that is not enough for us to finalize our conclusion. So what we'll do again will be to go back to the performance analysis, and then again we'll look at this information. We'll find out that now, I mean, the problem here is again the repair complex, which takes a longer time, and average of a 35 delay time to move from analyzing defect to informing the user. And then repair simple again has I mean a delay average delay time. So I think the problem again will be how quickly or to resolve or to optimize this process model. I think the organization will be looking at I mean, increasing the speed of moving from analyzing effect to these activities that are subsequently performed after it, right? So as soon as that is done, they should be maximizing the delay times or the throughput time to these next activities. So again, that was the first information that we can pass across to the owners or the process owners. Again, same thing like we did before. Again, we look at the total duration. Again, it's interesting because we find out that even though the mean duration shows us there are bits of delays, I mean, just about the same delay to pass information from analyzing. Then, and the best way to look at this information, because this puts the frequency in the rule. Because if we leave here and then go back to the frequency, we find out, see, this is just like about 22 activities, I mean, cases that goes through this part. And this is not actually where the bottlenecks rise, right? So I think the bottlenecks now will be between inform the user and the repair complaints, which is why it's always good to do the performance analysis, which gives you the main root cause of where the delays have. So for we to conclude this analysis, we will say that the delay or the bottlenecks within this organization will be, or for them to resolve the bottlenecks will be to optimize the time it takes from analyzing the defect to passing the information to the user, and also to optimize the amount of time being spent for the repair complexes. Maybe, for instance, they have to put in more resources, I mean, put in more probably experts that have been good in handling these complex cases, and I mean, put in more effort to optimize the delay time or time spent. I mean, in that case, in that way, the organizational process will be optimized properly and effectively. So this is one good thing about process mining. And when you finish your analysis, you can always then go ahead and save your file, right? So again, another good thing we could do would be to export. For instance, I can export this model to show. I mean, to put in my report, to put in to show the process owners, the people that have asked for the analysis. I mean, for your own information, for your references and documentation, right? So again, there are two things we can do here while we're exporting. So we can export this process map, and also we can export the event log itself, which is the event log that we used. So first, let me start with the process map. So, and there are different formats that you can export to this process map. You can export as a PDF file, as a PNG file, as a JPEG file, XML file, and other. So, for instance, if I choose to export as a PNG file, so what we'll do is to click on export, and then we need to choose the folder where I want the export to go. So in this case, I just want to save it in this folder that I have, and then I can save the process model as, I mean, yeah, so because that's what I named it, right? I mean, yeah, analysis, right? So I can just save it here. So that's it. I've exported this model now. If I want to see the model, all I just need to do is to go back to the folder where I saved it and just open it up. And now that's the model exported. So I can always view it. Same, you can export all any other model that you want. Like for instance, you have about 3 models I've created here. If I want to export this, I can export that. Right? I can export again as a process model, export that. This is the one that I was checking to print, but then save it again. That's the model. So just Disco. I mean, Disco is a very useful tool. I mean, I recommend that as well for process mining, and it's one of the most commonly process mining tools today because you could use it to do a lot of analysis. There are different tools. It allows you to set the threshold and to view the model in a way that gives you more useful information and the stuff and the rest. So I know the tool that I want us to look at again, especially to see if we can actually get the same information that we got from this analysis that we did today will be to, if I go back to the presentation, is the PROM framework. So Prem, I mean, is one of the early process mining tools that was developed, and one good thing about Prem is it has a lot of plugins or process mining algorithm. I mean, Disco is one of them. Like Disco is a process mining algorithm that is based on fuzzy mining. Right, it's a process mining tool that is based on fuzzy mining algorithm. Again, Chrome is a kind of open source or platform, a workbench, if I may say, that I mean, there is a lot of process mining algorithm, lots of plugins that are being provided as plugins that you could use for this analysis. Like we still have even the fuzzy miner as well in Chrome. We have other tools that you can use to do like performance checking, conversion of from one type of model to another. I mean, doing the process mining discovery and tags as well. So there are different versions as well of Chrome. We have the different versions for the Windows. We have different version for Mac and other platforms as well. So again, like we did with the Disco, all you just need to do is to, if you have Windows, just click. If you have 64-bit operating system, just make sure you are downloading the one that has a 64-bit. If you have a 32-bit operating system, just make sure you are downloading the 32-bit. Same for Mac, like when I was downloading, I had to download this. So just click on it and it downloads, open it up, install it, and then boom, you're done. But in this case, I will cancel this because I've already downloaded it and installed it on my system. So let's get to it. And So when you install it, install Prom, automatically, I mean, you will have a window that pops up again. So another interesting thing I would like to show you guys will be to now this is the data sets that I imported. I would like to use this data set again. I mean, that are used for this analysis in prompt to see if I can still do maybe a different kind of analysis that will still give me some information that I can relate this information to the one I found out in Disco. So again, in Disco, while you're handling data set, remember we're applying these filters. For instance, here I've applied a filter and it's giving me like 62% of the data. So again, if I want to go back to the original data set that I have, because I remember I've saved some copies here. So when I save some copy, it's like about some portion. For instance, the last one I did was the new bottleneck analysis. So this one was the completed one, looking at the events, the cases that were actually completed and are not waiting to be completed. So again, this I can now reset back to the original data set, right? And then apply a filter, and then it gives me the full information, which was about 1,104 cases, right? So again, we can go ahead and export this now. Now I can export the model like I've shown you guys before. Then I can go ahead and export this event logs again. If I want to export this event log, I can export it as a CVS file. I can export it as FSL file. I can export it as ZEX file for Prom, XML file for XML file for Prom, the older versions of Prom, audit report. So for now, I want to export this. I mean, Prom again supports any of these file types as well. Just to show you that we can convert from one type file type to another, I would like to export this as an XML file. Sorry, ZEX file, which is an XML file as well. So I will export this file again. Probably I will put it here. I will name it like Prom. So now I'm exporting this file as a ZEX file in this folder that I've created for this section of presentation. So I've already exported this file. So what we'll do will be to go and look at the file that I've exported, which is this one, then extract it. And then that's the CSV file. So we'll be using this file now for the Chrome analysis, right? So for we to import this file, you just need to go to import here, click on import, and then we'll navigate to the place where I saved the file. And then here, I saved it here. Oh, which is this. Oh, okay. I need to look at. So this is the ZEX file. This was the zip folder. So that's the ZEX file that I exported. So I can go ahead and import it into Prom. And then again, Prom gives you different options. Like sometimes if you're not quite sure what type of data you, I can always use like naive, this is buffered, map, DB sequence access. But sometimes I just recommend follow the default settings that Prom is giving you for the data. And then now we have our data set imported, which is this one, the repair example data set. So we've imported this data set in Chrome. So now we can go ahead and analyze this data. To analyze this data, all we just need to do is to click on this or this one, and then to analyze them. Now, Chrome gives us different options. Like I've mentioned, there are lots of plugins or algorithms that you can find in Chrome, and you need to choose. Most often, the green ones are the ones that or different types of analysis that you can do or you can perform on that data. Like we have the alpha miner, we have the BPMN analysis as well. You could do like BPMN model analysis and even like conformance checking as well. You could do like comparison check conformance as well. And I mean, lots of analysis that you could do. So, but I want to show us one example today, which is the inductive visual miner. So again, for you to search for any plugin or algorithm, once you know the name of the algorithm, instead of going through the list that you have here, I can still go through the list to find out whichever algorithm I want to use. So, for instance, the algorithm I'm looking for is the inductive visual miner. So all you just need to do is to type it up. So this is the algorithm that I want to use on this data set. So I'm trying to mine with inductive visual miner. And then once I select that, I'll just click start. And boom. So from now reconstructs the process model and gives us an overview of what this process looks like. Again, we'll have what we call the thresholds as well that you can always set to view your processes in in a view that is quite intuitive. So I think this is much intuitive for us. Again, typical process. I mean, we have the cases, 1,104 cases that goes through the register, and then goes through analyze defect, and then you see that it goes through again these processes that can be run concurrently. Remember, these you see the plus sign, it means that these activities can be run concurrently. So again, we have the repair simple, we have the repair complex, and then we have inform user, and then test, and then archive. So this is a process tree now again for these our reference data sets. And there are quite a couple of things that we could do in this process mining too. First thing I would like to show you will be to we can look at the paths and deviations, right, to see more information that we will have, just to see what's going on here. We'll find out again there is some deviations that is going on here, and it's right around again the repair simple and the complaints. You can see the complaints again and the repair simple have quite a deviation that is going on around complaint simple, test repair, and then towards archive, right? So again, we can go ahead and try to, see you can set your thresholds just to see in more details where the bottlenecks lies here. We find out again between here, there's a lot of bottlenecks around the repair complex, and we have the specific pool that joins, but I think like find out initially before we can conclusively say that this bottleneck is being handled, and that's like the throughput, the points that we find out in the throughput type that we find out the last time that goes here. So again, the other information again that we could find out, again, we can find out the another one that I strongly recommend is the pattern sojourn time. The pattern sojourn time will give you on average what the time it takes to complete each activity. So again, we can find out that the inform user and the repair compliance activity takes a bit of longer time as well. Yeah. So here it's a bit quite clearer. So we can see that these are the thick ones that actually takes a bit of a longer time again to complete. So this is the sojourn time again. And another interesting one that I still see is the service time, which is the time it takes to complete each of these activities. So this takes about to about 23 minutes to complete, and this takes about 7 minutes to complete. So again, we can still see like from the information we got from the last analysis we did in this code that the bottlenecks, is around the repair complex. So if I would write a report or recommendation based on this analysis, I will advise the company to put more resources to check the throughput time between analyzing defects and the complaints repairs, and also the amount of time that is being spent to do the repair complex, to do the complex repairs, basically. So yeah, that's another new information. Also, we could see look at the queues, right, to see the queues, how many times, how many queues we have pending in these activities, maybe the activities that are not yet completed and others. So, I mean, these are the useful information that we could find. So, you can, a very useful analysis to do is the paths and deviations to see where the deviation lies. Another important analysis to do will be to look at the sojourn times to see how much time it takes for each of these activities to be completed. And again, another useful thing you could do, we can do with this if thing. One thing about inductive visual manner is it allows you to view the flow of these activities to see which individual parts. So you could do animations to view it and see what information or what's going on. Yeah, so we'll go back to the parts and then the animation. Each of these yellow dots are the different cases that comes into the model. And yeah, and then if we go back to this one, to the deviations. So once we find out, for instance, we want to use this for a report again, or we want to store it for subsequent referencing or to show the process owners what's going on across the organizational process. So we can always do the export model, and for you to do the export model, you can we need to first choose which export view you want. Like we looked at in the presentation before, we have different types. So you can export this as a process tree, or you can export as a battery net. So whichever one you want to choose, just choose battery net, right, or as process tree. So first, let's just export as battery net, and then export view. So all you need to do is to, again, choose a folder where you want to so we want to store it, like here, and then we'll save it here. Okay, let's save it directly here, and then we can say inductive visual minor model. Huh? Yeah. Then again, it gives you different formats that you can save it as. For instance, I can choose to save it as a PNG file. Save. Then if I go back here, so that's the model. So you can always export again for your use, for your report, and for storage, and for useful information that you need to communicate your findings. So I think I mean that's quite a little bit of a demonstration on how we can use process mining tools to provide new information. And if I would say from this analysis that we've done today, I would say that the company that we are looking at these data sets, I mean, we have to focus on the time it takes from analyzing the defects to taking it to for the complex repairs or for informing the user. That would be the first area I would recommend the company to look at or invest more optimization procedures for. And then another one is to maximize or, I mean, adding more resources for the repair complex, I mean, the complex repairs, and to make sure that the delays, amount of time that is being delayed for that activity to be completed is being resolved. So I think with that, I've been able to demonstrate how we can put data science in action. And going back to our presentation, yeah, like I said, these are there are a number of tools that we use that are very useful. A lot of them offer free, open source, while some give like academic initiative, and some will give you trial period for you to choose and identify what you want. So to finalize this section today, I will be looking at the process mining in total. So process mining in general serves as the bridge between the process modeling and data mining procedures. So process mining will allow you to use data mining techniques to discover what we call the process models, and then allows you to do further analysis of these discovered models. I mean, it's not only limited to the business processes and real-time data analysis, but can also be used to provide new and innovative ways to analyze, discover, monitor, and enhance any given process, so long as the same data contains the minimum requirement to perform a process mining, which is the activity name and the case ID, and then there's a timestamp to help provide the sequences of activities. And what are the lessons we learned today? I mean, the main lesson for us today is the big data and augmented intelligence, right? Most organization processes are complex because the amount of data available today has outgrown human expectation and the processing capabilities of existing tools. But however, the good news is there is a solution. If we can understand this increasing complex data and model, this advanced level of intelligence, then we can start to realize the power of process mining. In other words, process mining is data science in action. Data science is augmented intelligence, which augmented intelligence means computing power and human input. What is human input? Human input is both you and I, right? We currently live in a world that is made up of about 7 billion people, and at some point, we come across these everyday processes. Organizations are looking at how to maximize their processes. Individuals are looking at how to maximize their everyday activity. So at some point, I mean, we need this computational power to help, reinforce or empower our decision-making capabilities. I mean, because sometimes we can't make these decisions just by, using, quite a lot of time we can do some decisions using common sense. But these tools, what they do is to provide you with facts, insights that you use to actually, conclude, or evidence that you use to conclude your decisions, to say, yes, this is where I need to throw more emphasis on in this organizational process. This is where I need to add in more effort. This is where I need to put in more resources. So that is data science in general. And also I have some useful link which I've used for this section today, and also I recommend for people to go. There is this Coursera. This Coursera is a so it's a course that is being offered on process mining. It's called Process Mining Data Science in Action, right? So I do strongly recommend for anyone that wants to dive into the process mining concept to, a lot of times, think you can enroll for free. It's a free enrollment, and the course starts approximately 30 hours. It takes about 30 hours to complete the course. And I think the course was for like 6 weeks or something each time, and it's free. And that's a very good way, or a very for those of us that will have an interest in doing process mining, or using process mining, or diving into the field, or how to get intuitive with these tools, and know about process mining in general and how the impact is making currently in literature. Then, I would recommend that you sign up to this platform. The other one is the process mining hub, where you can download the prompt tools. Yeah, I always find this link very useful as well, because they also have like the first book that was written in process mining. I think this is the second edition of the book, and you have a lot of useful information there that you can always. This is the first edition of the book, and then you can order it from any of these publishers or service providers. So again, if we go back to the main, and then there is a lot of publications. Again, you can find it for those of us that are into research. Yeah, you can find a lot of publications, current publications within the process mining field that you could use for your reports, for your research. For your academic activities as well. And then there are PhD theses, and then there are presentations as well in this link. But the main thing I want to show you in this link is Chrome as well, like with Chrome. You can always download the latest version of the Chrome tool again from these websites. And also, there are quite a number of data sets as well that you could use to, like if you click on event logs, then there are a number of data sets as well that you can download just to test out your process mining techniques and see what informations, and then probably go ahead and can be applying these things to other, yeah, other settings. Again, I've shown you guys the prompts that, and then this is the Disco, the Flossicom website I showed you earlier on. And then again, there is this website where you can find the different types of data mining vendors, process mining vendors, right? The different types of process mining tools that you can use for the process mining analysis. And then actually, let's go to the website. Yeah, you can see like best process mining softwares. We have like Selenium. I've shown you people some of these websites as well. Mine a Signal View. I mean, there are lots of tools here that you can use. You can use to perform the process mining, and then we have this link again that gives you access to some data sets that you could use for your process mining. I think this is provided on the website of IE Tax for some process mining. I mean, these are the organization IEEE Tax for some process mining. These are the organization responsible to standardizing the process mining field. I mean, the process mining is still a young research field that have existed for just 2 decades now, and is making an impact. Many organizations are using it. So yeah, you can go ahead and get a lot of this data and try them out in your process mining analysis, and then probably get your research done. And or you can also filter these based on, for instance, if I want the files that are available in CVS file, I can filter. If I want the files that is available in CS file, I can filter them according to the type of file. If I want the file that is in XML file, these two are the ones that is provided in MSML file. So yeah, then again, there is another repository again where you can get event data as well. Yeah. So there's a lot of data available out there which you can use to try out your process mining. Again, this is the IE tax force on IEEE tax force on process mining event logs, and then BPM challenge logs. Then there are lots of events data as well that you can download as well to try out your process mining technique. And I think with this information, the whole general picture of our discussion today is that people you can get along and get these data sets. I mean, apply the main essence of the data science, which is how do I extract useful information from these data sets? How do I extract real insights that can be useful for not only for me to understand what's going on in this data set, but also for me to understand how I can leverage this information to improve any given process. And that's the wider scope or the spectrum or the essence of process mining. And feel free to share your questions with me. Feel free to send me your questions and answer, and I will try my best and to get back to you on your questions and try to support you in any way you want. I mean, I'm glad that we're now in an area whereby, I mean, the youth are empowered. I mean, we're all willing to adapt the concept of artificial intelligence, data science, process mining. I mean, trying to apply these techniques to make use of not just the process of the environment that is around us, but to make useful, I mean, good use of these data sets that are being just stored lying down in these database systems, right? You can extract them, you can use them to provide useful information for these organizations that using these data sets. And I hope I've been able to share my view. And I am really happy that we are all moving it towards these new ways of viewing and analyzing this data. And I'm really much excited and happy to be sharing a small part of that, which I know will benefit lots of you out there. So feel free to contact me, and then I will be more than pleased to answer your question. Thank you.